Good evening. We're looking at center of mass. Simplistically, we're just dealing with one dimension, things like a seesaw.
I'm sorry, Professor, when this course was made, is it somehow related to physics? Is it like somehow related to physics?
Center of mass is physics,
I'm taking
yes.
physics right now, and it's like,
Yes.
not the first topic that is like, exactly.
Yeah. This is a physics application, so is work. It's usually the biggest application of math is physics. And so let's say this is a seesaw. You have two masses. The center of mass is the point where it's balanced. So there are several cases for center of mass. You have one-dimensional point mass. Right, so that'd be like this case here. You can have a two-dimensional point mass. Let's add another one. And then the center of mass would just be I don't want to say balanced because it's not really balanced, but think of it like an orbiting system. It's where those points would orbit. There would also be three-dimensional center of mass, point mass. I'm not going to worry about that in this class. We also have center of mass of a thin sheet called a lamina. So again, that is where would you have to hold the sheet that's perfectly balanced. Several cases with density. So you can have variable density or constant density. I'm going to start with. You can have constant density, right? So the density of the sheet is constant throughout the entire sheet. You can have a density that varies in only one dimension, right? So it only varies either horizontally or vertically. Or you could have it where density varies in two dimensions. Again, that would require Calc 3, so we're not going to consider that case. If we're dealing with a point mass system, let's start with one dimension. Then your center of mass is the point. You take the sum of the mass times its location. Right, so M1, in this case, M1x1 plus M2x2, and then divide by the total mass M1 plus M2. That would be the point where the center of mass is located. For 2 dimensions, we have to consider what's called moments. There are 2 of them. There's the x moment and the y moment. Do this way. It's going to be the x-coordinate for the center of mass is the sum of the masses times its y-coordinate divided by total mass. This is known, the y times m, as the y moment of inertia. It's being measured, the x moment, it's being measured from the x-axis. Right, that's why you use the y-coordinate. So this is just the sum of the x moments divided by total mass. Right, and then the y would just be sum of the y moments, which is the x-coordinate times mass, divided by total mass, sum of the masses. If you're dealing with a lamina, though, you have an infinite number of points, right?
What's the difference between the y moment over there over on the right and the one on the left over there? Is this the same?
Yes.
Oh, okay.
Right, in this case, it's one-dimensional.
Okay.
Right, so we don't really call it a moment in a sense because it's just one dimension we're dealing with, but yeah, that is a y moment.
Okay.
So let's say we have a lamina of mass density rho. Total mass dx. It's the integral over the interval that the lamina covers of rho dx.
Should that be mass times density or just mass density?
That's mass density. It's called mass density.
So it's like one phrase?
Yeah.
Okay.
Y moment. This way. X times rho. The wrong page, that's why. This is going to be for a thin wire. I don't feel like rewriting it. Alright, so one-dimensional thin wire. Very thin, so we can ignore the second dimension. For a lamina, mass is density times the difference in the functions. Right, so the region is always going to be bounded by two functions. So really, if you look here, the mass is density times length, which makes sense. Here, mass is density times area, which again makes sense. The Y moment X times rho, then times the difference. It's the X moment that's a problem. To find the X moment, it'd be the integral from C to D, where C to D represents the interval along the y-axis that the region covers. Y times rho times the difference of the functions of y that the region is bounded by. However, that is generally a pain to calculate. Converting from X to Y is generally a pain. So another way we can write this no X. Rho times f squared minus g squared. All times 1/2. That is generally the better way of calculating it.
Okay, is f squared of x the same as parentheses f of x.
Yes.
In parentheses, okay.
All right, so that's just notation when you want to raise a function to a power. Right, think of the traits. Right, sine squared.
Yeah.
Questions? Yes. So we're going to start with a wire. I should specify. Then the center of mass, the x-coordinate is my divided by m. The y moment would be mx divided by m. And here, your center of mass would be my divided by m. So we have a very thin wire. Extends from -3 to +3. And we're told it has a mass density of 1 plus 3x squared. Right, so the density of the wire is not constant, right? It depends on where on the wire you're located. The first thing that we need is total mass. So all we do is integrate the density function. X plus x cubed from -3 to +3. Six plus 54, the mass is 60 units. So the moment of inertia integral of x times your density. What, x plus 3x cubed. Find that antiderivative. X squared over 2 plus 3x to the 4th over 4. Vary that to from -3 to 3. Zero. Center of mass is located right at 0, the origin, which happens to be the halfway point of the water.
If it says my, are we looking for x coordinate? At my?
So it's for the x coordinate, but it's called the y moment. Right, because what we're doing is we're measuring it from the y-axis. That's why it's called the y moment. Right, so it is a little confusing until you get the hang of it. Right, you need the y moment for the x and the x moment for the y. This should make sense. The 1 plus 3x squared is even. So from minus 3 to 0 and from 0 to 3, the densities are the same. If density is the same, that means that the mass on the first half and the mass on the second half are identical. Right, in this case, total mass was 60. You have 30 units on here, 30 units on here. That's the point of the center of mass. So this little e is right in the center of the wire. Sticking with the wire, a couple of things are going to change here. All right, wire extends 0 to 3 this time. Row of x is now piecewise. 4 units from 0 to 2. 5 units, 2 to 3. All right, so the first 2/3 is going to have a density of, constant density of 4. And then the last third of the wire is going to be a constant density of 5. Total mass. It's the integral 0 to 3 rho of x dx. But our rho is piecewise, so you have to split the integral into 2, right? Where is it split?
So you go 0 to 2 first, and then 2 to 3. After.
So we're integrating 0 to 2 when, what are we integrating?
That would be the 4, yeah.
And then 2 to 3, we integrate 5. These are not, well, I mean, they're technically functions, but they're constants, which makes these integrals really easy.
Yeah.
Length is 2 times 4 is 8. Length is 1 times 5. Total mass is 13. Y moment, the integral, x times the density. Which means, again,
Split it.
that's 2x squared from 0 to 2. So x squared from 0 to 2 is just 4. Boy, this is 5 halves x squared, so we're going to get what? 9 minus 4 is 5. 25 halves. 4102 is the y moment. So the x center of mass, our position, 41 halves divided by 13. It's the y moment divided by total mass. (41/26). Which is less than 2.
Lost 60.
I don't think it reduces.
1 point. So it is greater than 1.5. Slightly greater than 1.5, right?
Yeah.
So it's going to be slightly to the right of the center of the wire. So probably maybe right about here, let's say. So now we have equal mass on either side. Now we're looking at laminas. When dealing with the lamina, center of mass is also called the centroid of the region. So something important to keep in mind about center of mass. When you took basic science, when you learned about the planets, the solar system, what did they tell you the planets orbit? The sun. That is not correct. They orbit the center of mass of the solar system. The center of mass happens to be within the sun, within the radius of the sun, which is why it looks like everything's orbiting the sun.
Is it the exact center of the sun?
No, it's not directly in the center.
Okay.
If you pay close enough attention, the sun wobbles. You see the sun kind of going. It's because the sun's also trying to orbit the center of mass. The moon doesn't orbit the Earth. Also orbiting a center of mass. We can essentially treat it as a 2-point mass system and say that's orbiting the center of mass of the Earth and the moon. Because the moon's also orbiting the sun, or not the sun, the center of mass of the solar system, but it also has to orbit Earth. So for purposes of that, we can just treat it as a 2-point system. If you look at Pluto, former planet, it also has a moon. It's called Charon. Moon is in air quotes. Because the center of mass of the Pluto-Charon system is actually between the two planets. So you actually see them orbiting each other if you observe them. One more reason why Pluto is not a planet. So that's where center of mass is important in the study of astronomy, cosmology. Here we're told, region has constant mass density rho. And the region is enclosed by two parabolas, x squared minus 3 and negative 2x squared.
Is rho that symbol that looks like a B? Okay.
It's the Greek letter rho.
Okay.
So it's constant mass density. So total mass. Since rho is constant, it's not going to have to be in the integral, right? Then we're going to integrate. So here's where we're going to have to do a little bit of algebra. Interval.
Just solve the equation. They're equal.
Yeah, set them equal, solve for x. We're going to get what? 3x squared is equal to 3. So that means x goes from minus 1 to 1. All right, points of intersection will be negative 1 and positive 1. Which function is larger? I'll plug in 0. It's the easiest one. You get negative 3 versus 0. What's larger?
0.
Negative 2x squared is the larger function. So there's the setup for our mass. Simplify that. That'll be negative 3x squared plus 3. Antiderivative, negative x cubed plus 3x. That'll be negative 2. That would be 6. So 4 row. Y moment. Rho times the integral, minus 1 to 1, of x times negative 3x squared plus 3. 3x to the 4th over 4, right?
Yeah.
Plus 3x squared over 2. From minus 1 to 1. That is a big goose egg. So, the x moment. While you could certainly find a function of y, problem is you're going to have a total of 4 regions, I believe you have to look at. Maybe 2, because you're going to wind up with plus or minus. That's not ideal. Which is why we use that second formula. Rho over 2, integral from minus 1 to 1. Negative 2x squared quantity squared minus x squared minus 3 quantity squared. That's 4x to the 4th. I'm also going to have x to the 4th. Leaves us with 3x to the 4th. Negative 6x squared, twice the product, and then minus. And then minus 9. What is our antiderivative?
Let's see. 3/5 x to the 5th. 1/3 x squared, x cubed, I mean, plus 1.
Not 1/3.
No, 3x cubed. Wouldn't it be 6 over, no, 2x cubed, yeah. Minus 9x.
Goes from minus 1 to 1. Six fifths plus 4 minus 18. I'll just write it above. That's 6/5, 4, 18. Negative 14. So what is 6/5 minus 14? What is it as an improper fraction?
Oh, minus 14?
Yeah, so it's 6/5 minus 14.
So it's 12.
So what's 5 times 14? 60?
64 over 5.
70.
Yeah, be negative 64 fifths. And then times the rho over 2. Negative 32 rho over 5 is our x moment. So there are several ways to write some math. You can write as an ordered pair, or you can actually write each coordinate individually. I don't care. So x center of mass, you may also see it written as just x bar. Oh, this one's easy. It's just 0. The y center of mass. Negative 32 rho over 5 divided by 4 rho. Which is what? Negative 8/5. Oh. When finding the center of mass, did density even matter?
I guess not.
No, it doesn't, right? So if you get constant mass density rho, you can just treat rho as 1. Which is what I'm going to do in the future problems. But you have to be careful. You have to read what the question is actually asking. If it's just asking for center of mass, just ignore the rho, right? Treat it as 1. If it's asking for the mass and the moments, you do need rho. Right? Mass there is not 4. It's 4 times rho. It's 4 times the density. Oh, are you kidding me? I freaking hate when it does this. Deletes my pin. Go away. You can go away, please. Here are what I wanted. What else is on here that I don't want? Because I should have documentation up here as well. Let's go ahead and remove you. There's the documentation. Oh, I probably don't want you. I can get rid of you. Yeah, I do need straw poll. That's good enough. And what's today, March 27th? 2024S, March 27th. View magnification 200. Okay. So I'm going to show you how we can plot both the lamina and the center of mass. So let's define lamina. I'm just going to plot the two functions, right? I only care about -1 to 1. Now I'm going to set top style to black. I don't care about filling. Right. So normally, let's just do this for now. It would give us that. But I actually don't care about the axes this time. So let's turn them off. Right? There's our sheet. Now for the centroid. So it's just a point. I'm going to use the graphics command because I want it to give me a graphic. Specifically, I just want it to give me a point. Let's go with the actual point first. So what was the point? 0, -8/5. So the reason I have this also embraces, right, is because I also want to define how I want the point to look. So the graphics command is going to give me the point, and then I can also define how I want the point. I can have it be a color. I can adjust its size. Let's do medium for right now. Let's see what that looks like. Except I forgot to close that out. There we go. Let's see how that looks. Perfect. And then all I have to do, I don't know why it uses such a large region, but whatever. Now, show there you go. Well, if that's the case, with enough time, I can make it look like the Eye of Sauron.
Yeah.
Okay. Now, obviously, if I was just asking you to, I don't know, say I gave you an assignment and I said, plot this lamina with its center of mass, you wouldn't have to actually calculate by hand all that, would you?
It's not, you can put it in there.
No, you can just define, I could just define, I could do this. Oh, I don't think it's going to let me do an underscore, is it? Crap. That's right, I'm not going to be able to do underscores here, so I can just do this. And then define it to be the integrals, right? Do the same thing for y. And then up under the point, just do x com comma y com. And I just have it all execute at once. Let's actually do that for this one. And then I'll go over and I'll calculate it by hand. Yeah, that's not really worded well. Let me fix the way that's worded. Find the centroid of the region with constant mass density rho. But there, that's better. Right, because the centroid doesn't have a mass density, it's the lamina that has mass density. So we're looking at the lamina. It's bounded by the x-axis and the curve y equals cosine of x, where x is going to go from minus pi over 2 to pi over 2. Okay. Where's my mouse? There you are. Okay. So let's do this. We have two functions. Technically, we only have one. But I'm going to write out two. We have cosine of x, but we also have 0, right? Because it's being bounded by the y-axis. Or I'm sorry, it's being bounded by the x-axis, so I don't want that. I'm going to need it when I go to plot. So our lamina, let's define that as a contour plot. Y equals f of x and x equals 0. We're going to need, oh, actually we don't. That's right, they actually gave us minus pi over 2 to pi over 2. And what should y go from? What do we think for this region? That's too large.
Should it just be negative pi over 2 to pi over 2?
So minus pi over 2 to pi over 2, is cosine positive or negative? Positive. Since we're bounded by the x-axis, that means the lower bound is going to be 0 for y. What's the largest that cosine can be over minus pi over 2 to pi over 2? 1. So y should just go 0 to 1. So I'm thinking, if I do that, is it going to show x equals 0? Thank you. And we'll see. All right, set the contour style to any color you want. I'm just going to set the black. And I'm going to shut off the frame, right? Because remember, contour puts it around that box. I don't have to worry about the axes because the axes are already turned off for this. And that should be all I need. Let's define M. So total mass. It's an integral, right?
Yeah.
Be what? So first off, we've established that f of x is going to be positive, right? So it's always going to be the larger function. So it's just going to be the integral of f of x from minus pi over 2 to pi over 2. Let's do my next. X times f of x. Mx 1/2. Then we're integrating. Our centroid. Graphics. Point. I'm just going to do it this way. I'm not going to do xcom and ycom. It's my over m, right? Comma, mx over m. And again, let's just make it a medium point. And then we just want to show the centroid on the lamina. Right. I didn't need contour plot. The x-axis is y equals 0. I'm a dum-dum. That's okay. Yeah, so it's not actually showing the y equals 0, which is what I was afraid of. So I am going to go slightly under 0 just so I can get that line. So let's calculate that actual point. And then we will check I'm just going to do p times. Or no. Because I do not feel like typing in row. you in the wrong place. There you go. So I'm going to use P for rho. And I'll just execute that after we calculate the actual mass and everything. So what I'm going to do is for these calculations, I'm going to say without loss of generality, let rho equal 1. So essentially I'm just ignoring rho. Total mass. The integral from minus pi over 2 to pi over 2 of cosine, right? Which equals sine of x from minus pi over 2 to pi over 2. What is that, 2?
Yeah.
Y moment. Oh gosh. Minus pi over 2 to pi over 2 integral of x cosine of x dx. Oh boy. How would you calculate that?
By parts.
That's integration by parts. But we also have a table. Number 38 on the table. It's going to give us cosine of x plus x sine of x from minus pi over 2 to pi over 2. Cosine of x is 0. This is also 0. Sine of pi over 2 is 1 times pi over 2. Sine of negative pi over 2 is negative 1 times negative pi over 2 is positive pi over 2. This is pi over 2 minus pi over 2. The y moment is 0. X moment, 1/2 integral minus pi over 2 to pi over 2 of cosine squared x dx. How would you evaluate this?
I think that's on the table.
Could use the table. You could also remember that cosine squared is 1/2 of 1 plus cosine 2x. And so integral of 1, that's where the 1/4 is coming from. I'm factoring out that 1/2. And 1/2 times 1/2. Then you have antiderivative of 1 is x. Yeah. Antiderivative of cosine 2x. It's a half sine of 2x. From minus pi over 2 to pi over 2. This is going to be 0. Right, because it's sine of pi and sine of minus pi. 0. So it's just this. Pi over 2 plus pi over 2. Pi. Makes the x moment pi over 4. What does that make the center, the x coordinate of the center of mass?
Zero.
And what about the y?
4.
Is it pi over 8?
Pi over 8.
Yeah.
Pi over 4 divided by mass, 2. I'm going to add 2 more lines. Let's see if we were right. Yay! We were right. It's always nice when you do math successfully, isn't it? Find the centroid of the region with constant mass density cut from the first quadrant by the circle of radius 3 with center at the origin. Okay. We're going to need a function. What's f of x going to be?
See the problem again?
It would be x squared plus y squared equals.
Well, that's the equation of a circle. That's not the function that we need. But you can use it to find the function.
Y squared would be 9.
Mm-hmm. So what is that function of x?
Okay, so we have to take that and solve for x, basically.
No, not solving for x. You're solving as a function of x.
Function of that.
Solve for y.
You have to solve for y.
Okay.
What do you get?
The square root of 9 minus x squared.
So you have to also make sure that's going to be the correct quadrant. Is that quadrant 1?
Yeah,
Yes.
it was positive.
Y is positive. Quadrant 1, Y is positive.
Yeah.
Perfect. So that matches. All right. Contour plot. So we're obviously going to have f of x. Y equals f of x. It's also going to be cut by 2 other curves. So because it's the first quadrant, it's going to be cut by the 2 axes, the y-axis and the x-axis. What does x go from?
It's 0 to 3.
0 to 3. And what does y go from?
Would it also be 0 to 3?
So again, we're going to have an issue with this because it's not going to show the axes. What I could do is why did I do frame false? What I could do is I could turn on the axes so I get the lines. Change the style to be bold. And just turn off the ticks so that they're just bold lines. We'll see how that looks. Uh-oh. All right, so we're integrating. For the mass, what do we integrate? Just f of x, isn't it? It's only one function that we're dealing with. Did it again. We're going to go from 0 to 3. This isn't going to change, is it? Other than this goes 0 to 3. And this doesn't change, other than it goes 0 to 3. And I shouldn't have to change anything else. That worked out kind of nicely. For the next, let's say 15 minutes, go ahead and find the coordinates for the center of mass. And then I'll run that to see if you got it right. that's what you should have gotten. Mass is 9 pi over 4. Both moments are 9 if you take rho to be 1. And the center of mass is located at 4 over pi, 4 over pi. So for the mass, it's the integral of the square root, right? Which would normally require trig sub. However, if you think of integrals as areas, because that's what they are, that integral is just the area of that quarter circle. And what's the area of a circle? Pi r squared. So the area of our circle is 9 pi, which would make area of that quarter circle 9 pi over 4. So total mass is 9 pi over 4 that way. You don't have to use trig sub. You can if you want to. I won't stop you. But if you remember, an integral is an area, right? So if it's an easy formula, it's an easy area formula like a circle. Do that instead of trying to find the actual integral. Any questions on center of mass?
Center of mass for the x center of mass is my over n.
Yes, it's the y moment divided by mass. And then the y coordinate is the x moment divided by mass.
Okay.
Right? No really new assignments today. You can at this point work on the assignment 15 on My Open Math. Remember, those assignments will be due April 17th. And your exam corrections for half credit back is due Monday. Have a wonderful weekend. See you again on Monday.